Welcome to The Explainer. Today, we are pulling back the curtain on the invisible world of digital memory. We're going to find out how every single photo, every file, every app you own is stored, starting from one simple switch and building up to billions of files. Okay, let's just dive right in. Have you ever really thought about how your phone can hold, literally a library's worth of information in the palm of your hand? It's not magic. It's memory. And believe it or not, the whole thing starts with the ability to store just a single one or a single zero. Let's get into it. So before you can even dream of building a gigabyte, you have to completely master the bit. To store anything at all, we first need a super reliable way to just hold one single piece of information and keep it there. This is the absolute foundation for everything else. And here it is. Meet the hero of our story, the flip-flop. This is the atom of digital memory. It's a really simple circuit that can be locked into one of two states, on or off, 0 or 1, kind of like a light switch. This simple ability to hold a state is what makes everything else possible. And what's truly wild is that this idea has been around for over 100 years. The first flip-flop was invented way back in 1918. It's just a powerful reminder that all of our cutting-edge tech today is really built on the shoulders of giants. So, okay, we figured out how to store one bit. Great. But your computer needs to store billions of them just to boot up. So how in the world do we scale from one tiny little flip-flop to the massive memory chips that power our lives today? Well, the answer is all about organization on a massive scale. We take millions, or these days billions, of these tiny memory cells, and we arrange them into this perfectly structured grid. You can literally picture it like a city map with streets and avenues. This giant grid is what we call a memory array. Now, not all memory is created equal. You've probably heard of RAM, but the two main types, SRAM and DRAM, represent this classic engineering trade-off. Think of SRAM as the Ferrari. It's incredibly fast and stable. DRAM, on the other hand, is like a city bus. It's way more efficient and cheaper, but it needs a constant little jolt of energy, a refresh, just to keep it on track. Okay, so we've built our city of billions of bits. It's huge, but a city isn't very useful if you can't find a specific house on a specific street, right? So how does the computer navigate this metropolis of data? This is the real challenge, isn't it? The computer has to find and grab data from one specific memory cell out of billions, and it has to do it almost instantly. Let's take a look at the incredible system that makes this high-speed navigation possible. It all comes down to this really logical four-step process. First, the computer sends out an address. Then, the row decoder selects the street, and the column decoder pinpoints the house number. But honestly, the real magic, the part that makes it all work, happens in that final step with something called the sense amplifier. You have to understand, the electrical signal stored in a modern memory cell is, it's unbelievably tiny. It's like trying to hear a single person whisper in a sold-out football stadium. The sense amplifier is basically a super sensitive microphone that can pick up that faint whisper and boost it into a loud, clear signal that the rest of the computer can actually understand. Without it, the whole system would be deaf. So far, we've only been talking about memory that needs power to remember anything. The second you turn your computer off, it's all gone. So now let's explore a whole different kind of memory, the kind that holds onto your data even when the power is off. Welcome to the world of permanent storage. And the story of how we got here is just this fantastic journey of innovation. We started with something called mask ROM, where the data was literally baked into the chip at the factory. You could never change it. Then came EEPROM, which was a huge leap because you could actually erase it with UV light. And that innovation eventually led us to the flash memory that we all use every single day in our phones, our USB drives, and our SSDs. And that brings us to a really neat bit of trivia. Ever wonder why they call it flash memory? Well, its inventor thought the process of erasing an entire block of data all at once was so incredibly fast, it reminded him of the bright burst of light from a camera's flash. And the name just stuck. All right, now for one final twist that's going to connect all of these ideas together in a way you might not expect. And it brings us right back to the camera sitting in your pocket. It sounds like a riddle, right? What could a memory chip possibly have in common with a digital camera sensor? The answer is so elegant, and it completely reframes what we even think of as memory. Okay, so here's the mind-blowing connection. A digital camera sensor is built just like a memory array. It's a massive grid of tiny cells. But instead of storing bits, each cell is designed to capture photons of light. When light hits a cell, it creates a small electrical charge, and the sensor stores those charges, creating a perfect snapshot of the world. It's literally memory for light. And that brings our whole journey full circle. We started with that humble little flip-flop, a single bit. We scaled it up to massive RAM arrays that run our computers, and we ended with a camera sensor, which is really just a specialized memory array that captures our memories. It's incredible how it's all built on the same fundamental principles. So if you found this look into the digital world around us helpful, and you want to see more explainers just like this one, there are a few really simple things you can do that help us out a ton. Please just take a second to hit that like button. It really does help the channel grow. Make sure you subscribe for more deep dives into complex tech. And definitely don't forget to ring that notification bell, because you won't want to miss our next explainer when we tackle filters and oscillators. Let us know down in the comments what piece of everyday technology you want to see us break down next. Thanks for watching, and we'll see you in the next one.